Okay, so now we're going to discuss division of fractions, one of the more difficult concepts in all of elementary school mathematics. As we have discussed with pretty much all of our arithmetic operations with both whole numbers and fractions, we don't want to just tell our students a procedure. We want to give them a convincing argument that for why the correct procedure is correct. And that is very evident with division of fractions, because oftentimes division of fractions is simply taught by the so-called invert and multiply rule. But even that name is misleading. For example, if you knew nothing else about fractions and you were simply told invert and multiply to solve the problem, and you were asked to apply a so-called invert and multiply technique to 2/3 divided by 3/5, the way I would interpret that is to invert and then multiply. So if I were told invert and multiply, the way I would interpret 2/3 divided by 3/5 is to invert 2/3 as 3/2 and then multiply that by 3/5. And then I would use my rule for multiplying by fractions to multiply straight across the top and the bottom to obtain 9/10 as an answer. Now, we know that that is the incorrect answer. So if we just, So if we just rely on phrases like invert and multiply to teach something as complicated as division of fractions, we can see how easily that kids can misunderstand the topic. Okay? So what we do instead, just like what we've done for every other operation, is we want to give convincing arguments for why so-called multiplying by the reciprocal is the correct way to divide fractions. And what we want to do is we want to look at all types of problems that could involve division of fractions. So frankly, if we have a whole number divided by a whole number, that can result in a fraction as an answer. So we're going to start with the case where we have a whole number divided by a whole number. Okay? In each of these cases, we are going to take a look at a particular problem that is characteristic of a general type of problem. So for example, if we want to illustrate whole number divided by whole number, we might pick the division problem 5 divided by 2. Now what we want to do in this case is come up with a word problem that models 5 divided by 2. And through the solution of this problem, we want to illustrate that 5 divided by 2 is equivalent to 5 times 1/2. Remember, in this discussion, we are not interested in getting the answers to these problems. What we want to show our students is that the way that we divide 5 by 2 is by multiplying 5 by 1/2. Right? We want to illustrate that the multiply by the reciprocal method is a valid method in each of these cases. Okay? So we might start by coming up with a word problem that clearly represents partitive division for 5 divided by 2. So for example, you and I wish to share 5 cookies equally. How many cookies will each of us receive? Okay? So again, students at this point have enough experience with division to recognize that this problem is solved with the arithmetic 5 divided by 2. Again, there are 5 things. You're going to split them equally 2 ways. That's a division problem 5 divided by 2. And now what we want to do is we just want to illustrate that in the solution of this problem, we see that the solution is found by taking 5 times 1/2, or multiplying 5 by 1/2. One way to do that is simply to split all these cookies in half. So with all these cookies, let's just cut them in half like so. And let's say you take all the top halves and I take all the bottom halves. Now the answer to this problem is how many cookies each of us receive. And by doing this, it's quite clear that each of us receive 5 halves of cookies, right? If I get all of the top halves, I get a half, I get a half, I get a half, I get a half, I get a half. I get 5 halves of cookies. So it's clear that the answer to this question, and at the beginning we knew that the question was solved by 5 divided by 2 because it represented partitive division for 5 divided by 2. But simply by splitting all these cookies in half, it's clear that the answer to this question is found by multiplying 5 times 1/2. That's what we want to get across here. I mean, yes, it's nice to know that the answer to this question is 5 halves or 2 1/2, but what's more important is that students are convinced that a way to solve division problems of whole numbers like this is to multiply by the reciprocal. So for example, in this case, 5 divided by 2 is equivalent to 5 times 1/2. Okay. Now, this isn't enough, unfortunately, because there are different types of fraction division problems that are going to come up. So this, frankly, doesn't even look like a fraction division problem. It's a whole number divided by a whole number problem that ends up having a fraction as an answer. what about situations in which either our dividend divisor or both are themselves our fractions? So we need to handle those cases as well, and we want to handle them much the same way we handled this case. We want to start with a general situation. So maybe our next situation that we look at will be a fraction divided by a whole number. And then we can proceed in much the same way we did before. We can come up with a particular example of a fraction divided by a whole number. So maybe our example is 2/3 divided by 4. And now we, of course, as teachers, we know what the answer, we know what we want to get across. What we want to get across here is not necessarily finding the answer. What we want to get across is that 2/3 divided by 4 is equivalent to 2/3 times 1/4. So that's our goal here, is to show that 2/3 divided by 4 equals 2/3 times 1/4. Because again, what are we trying to do? We're trying to convince students that multiplying by the reciprocal is the correct way to divide fractions. So the first thing we do is we come up with a word problem that it clearly represents 2/3 divided by 4. And we could use a similar problem to the last one. In the last problem, we had 5 things we wanted to share among 2 people. In this problem, we might have 2/3 of something, maybe 2/3 of a pizza, that we want to share among 4 people. So maybe that's our problem. 4 people wish to share 2/3 of a pizza. If each person receives the same amount, how much of a pizza does each person receive? So again, students have enough experience with partitive division to recognize that just in reading this problem, since we have 2/3 of something that we're splitting equally 4 ways, that the correct arithmetic needed to solve this problem is 2/3 divided by 4. And just like in the last problem, what we want to do is through the solution of this problem, we want to illustrate that the correct arithmetic needed to solve this problem, or this problem can be solved by multiplying 2/3 times 1/4. Running out of room here, so I'll draw the picture on the other board. Okay, so if we have 2/3 of a pizza, that might look something like this. So let's say the shaded part is gone. That's been eaten already. Okay, so we have 2/3 of a pizza that we want to split equally among 4 people. Okay, so one way of thinking of this is there's 2 really big pieces of pizza, and we want to split this 4 ways. Now, one way to physically, just imagine sitting at your kitchen table with a pizza cutter in your hand and 4 people around the table. What you're going to do, of course, is you're going to cut both of these remaining pieces in half to obtain 4 pieces, and that way each person can take 1 piece. So if we do that, and keep in mind, since we're dealing with fractions here, we want all of the parts of the whole to be exactly the same size, so I'm going to cut the missing piece in half as well. So if we do that, it's clear that each person now receives 1/4 of the 2/3 of the pizza that we started with, right? Because now there are 4 pieces of pizza, right? So each person is going to receive 1 piece of pizza. But in terms of fractions, what does 1 piece of pizza represent? 1 piece of pizza represents 1/4 of the 2/3 of the pizza was there originally. Okay? So each person receives mathematically or arithmetically, each person receives 1/4 of 2/3 of the pizza. But now we just have to recall the way we interpreted multiplication of fractions. The word of was used to represent multiplication. So 1/4 of 2/3 corresponds to this means 1/4 times 2/3. And of course, since the commutative property of multiplication certainly extends to fractions, 1/4 times 2/3 is equivalent to 2/3 times 1/4. Okay. So what we've illustrated just from having a pizza cutter in our hand, essentially, is that if we had 2/3 of a pizza that we started with, and we want to split it 4 ways, then each person is going to get 1/4 of the 2/3 of a pizza that we started with. 1/4 of 2/3 corresponds to the arithmetic 1/4 times 2/3. From the commutative property, we see that 1/4 times 2/3 is 2/3 times 1/4. Okay, so if we put it all together, on the surface, the original problem we knew was 2/3 divided by 4, because we had 2/3 of something that we're dividing equally 4 ways. So on the one hand, the problem was stated 2/3 divided by 4. But on the other hand, through our solution process, which just entailed simply cutting these pieces in half, we see that the arithmetic that can solve the problem for us is 2/3 times 1/4. Okay? So again, this is more evidence, and that's really what we're going after here, is more evidence that makes it convincing that the correct way to divide fractions is to multiply by the reciprocal. So in the first stage, we had a whole number divided by a whole number problem, and the solution of that problem indicated that the correct way to divide was by multiplying by the reciprocal. Here we had a fraction divided by a whole number, and the same thing came out. It turned out that multiplying by the reciprocal gave us the right answer. Okay? So what we're doing is we're accumulating evidence. In more and more cases, it is apparent that this is the way we're going to divide fractions. Okay? Now, some people may argue that we've done enough, that it's convincing enough. But one reason for actually going through all of the stages, for example, another stage might be, instead of a fraction divided by a whole number divided by a fraction. One reason for really going through all of these stages is that oftentimes when children are exposed to a certain idea, then they really focus in on what that very, very, very particular problem looks like. So they might have a thought process that is something like the following. Well, if it looks like a fraction divided by a whole number, this is the rule. But maybe they won't connect the same rule as being valid if the problem looks different. And a whole number divided by a fraction is going to look different than a fraction divided by a whole number. So that might be a reason for actually continuing this process with a whole number divided by a fraction and also a fraction divided by a fraction. So that's what we'll do here. Again, we're going to do the same thing we did before. We have a whole number divided by a fraction. We want to illustrate that in this case, the correct way of doing this is, again, multiplying by the reciprocal. So what we do is we come up with a word problem that we illustrate a whole number divided by a fraction, and we show that this as we just give a real-world solution to this problem, that the correct arithmetic that comes out in the wash is multiplying by the reciprocal. So an example here might be 4 divided by 1/3. That's a whole number divided by a fraction. Our goal, again, is not necessarily just to obtain the correct answer. Our goal instead is to illustrate or to show that 4 divided by 1/3 is exactly the same as, in this case, 4 times 3, because 3 is the reciprocal of 1/3. That's what we want to show. Okay. So, as we did in our previous 2 examples, we might come up with a problem. So let's say we have 4 candy bars are split into thirds. How many pieces are there? Now, this type of problem is actually a little bit different than the problems we've had before. The problems we've had before in our whole number divided by whole number case and our fraction divided by whole number case were cases of partitive division. This is actually a measurement division question, right? And it's important for students to be able to recognize, as they read this question, before you actually solve the problem, what arithmetic is needed to solve this problem. This is a problem that illustrates 4 divided by 1/3 with measurement division. So this is measurement division for 4 divided by 1/3. Again, remember our discussion of measurement division. An interpretive question that is asked with measurement division in this case would be, how many thirds make 4? And that's exactly what's being asked, right? We have 4 candy bars, we're splitting them each into thirds. We want to know how many thirds make 4. Again, my picture will go on the other board. This is a very easy picture to draw and interpret. The real world application of this is quite clear. Candy bars are actually easy to draw too, just draw bars. So if we have our 4 candy bars and we split them each into thirds, it is quite clear. Again, the 12 is not the important part of this process. The important part of this process is realizing that on the surface, the way this question was phrased, the arithmetic necessary to solve the problem was 4 divided by 1/3, because the question really asked, how many thirds make 4? That's a measurement interpretation for 4 divided by 1/3. But very clearly, in actually solving this problem, we see that the arithmetic that can be used to solve this problem is 4 times 3. So in this example, it's quite clear that 4 divided by 1/3 is equivalent to 4 times 3. Okay? Again, that's what we want to get across. So we have yet more evidence that the correct way to divide fractions is by multiplying by the reciprocal. Because again, in the whole number divided by whole number case, in the fraction divided by whole number case, and in the whole number divided by fraction case, in each case, the correct method for solving the problem was to multiply by the reciprocal of the divisor. Now, we have one more case left, which is the case of fraction divided by fraction. And this case is a little bit trickier to illustrate. We're going to approach it in the same way that we've approached. We'll approach it in the same way we approached the other cases, in that first we're just going to start with an example of a problem that's fraction divided by fraction. So maybe we will use the problem 1 3/4 divided by 2/3. This is a fraction divided by a fraction. Our goal, again, is to not necessarily get the right answer. Of course, that's always nice, but really what we want to illustrate is that this problem can be solved by multiplying 1 3/4 by 3/2. Oops. Our goal is to show that 1 3/4 divided by 2/3 is equal to 1 3/4 times 3/2. That's our goal. We're going to proceed as we've been doing. We want to come up with a word problem that represents 1 3/4 divided by 2/3. And then we want to illustrate that the solution of that problem is actually found by taking 1 3/4 multiplied by 3/2. Okay? Now, here's the tricky part of this. In the last 3 examples, it was pretty easy to come up with word problems that illustrated a whole number divided by a whole number, a fraction divided by a whole number, and a whole number divided by a fraction, just using partitive and measurement interpretations. That's a little trickier when we have a fraction divided by fraction, as we saw in a previous clip that discussed interpretations of division. Okay? Now, one way of thinking about, or the way that we can interpret partitive division in this case, if we choose to use partitive division, is to think of 1 3/4 divided by 2/3 can be interpreted as 1 3/4 is 2/3 of what? Again, if you recall our discussion of partitive division from before, when we translated it to a problem involving division of fractions, this is the language we use to interpret a question like 1 3/4 divided by 2/3 from a partitive perspective. But this is something that would definitely need to be reinforced to students because they probably hadn't seen it in a while. Okay? But the good news is that once we have this interpretation, it's a little bit easier to come up with word problems that reflect a situation like this. Okay? So our example could be something like, a jug containing 1 3/4 gallons of water is 2/3 full. how much water would the jug hold when filled to capacity? Now, if you just start by stating a problem like this, it is not very clear that the correct arithmetic needed to solve this problem is 1 3/4 divided by 2/3. It takes quite a bit of thought, actually, to get to that point. If we kind of flip it around like we did here, though, and kind of start with a partitive division perspective and remind students that 1 3/4 divided by 2/3 is interpreted as 1 3/4 is 2/3 of what, then perhaps the students themselves could come up with an example of a word problem that corresponds to 1 3/4 divided by 2/3. Either way, once we see a problem like this, we can interpret this problem as 1 3/4 is 2/3 of what. So on the surface, we understand that the arithmetic necessary to solve this problem is in fact 1 3/4 divided by 2/3. What we still left to do, of course, is to illustrate that actually solving this problem requires multiplying 1 3/4 by 3/2. And actually, we are going to use our model drawing technique to illustrate this. And in a later clip, we will go into more detail about how to use model drawing to solve word problems involving fractions, but we can give a good introduction here. And this is also a good point to mention that with arithmetic with whole numbers, we have a very kind of clear sequence, teaching sequence that we follow. We first discuss the operations, the concepts of the operations, the models and interpretations, and then we learn how to compute, so we learn the algorithms, and then after we've learned how to compute, we start solving word problems. With fraction division, however, word problems are integral, they're kind of learned at the same time or discussed at the same time as the actual operation of division of fractions. You've seen in every stage that we've gone through, we have motivated each stage with a word problem, and that's actually necessary at this stage as well. Okay, so if we wanted to draw a bar diagram that illustrates, in this case, let me rewrite the interpretive question. 1 3/4 is 2/3 of what? That's what's being asked here. So if we wanted to draw a bar diagram that reflects this question, then the what is going to be the question mark. The entire bar is going to be the question mark. And we need to know something about 2/3 of the entire bar. Okay, that implies that we are going to cut the bar into 3 pieces, and we are going to shade 2 of them. Now, the significance of the 1 3/4 is that the 1 3/4 is 2/3 of the bar, right? So 1 3/4 is equivalent to these 2 shaded pieces. Again, if you remember our discussion of the model drawing technique, we have a complete diagram. Okay? All of the information in the problem is reflected on this diagram. Okay? If you further remember from our discussion of model drawing that our next step in the process is a unit sentence. We want to interpret this diagram in the context of what we call a unit sentence. So we need to match a certain number of units in this problem to a certain quantity. That's actually pretty easy in fraction problems because by the very nature of fractions, all the pieces are a unit, they're all the same size. So in this case, it's pretty clear that 2 units is equivalent to 1 3/4. That will be our unit sentence. And I'm going to convert 1 3/4 to 7/4. So if 2 units is 7/4, we need to figure out what 3 units is equal to, right? That's going to give us the answer to this question. So if 2 units is 7/4, we remember from partitive division way back when, that if 2 units is 7/4, 1 unit is equal to 7/4 divided by 2. Now at this stage, we already should know how to solve this problem, right? We have already talked about a fraction divided by a whole number, then multiplying by the reciprocal is the correct way to solve this problem. So 7/4 divided by 2, we can carry out that operation. 7/4 times 1/2. And I'm not going to focus on, I know we're always tempted to go all the way and find the answer, but remember, the answer is not necessarily what we're really interested in right now. What we're interested in is showing that 1 3/4 divided by 2/3 is equivalent to 1 3/4 times 3/2. So I'm going to leave this as 7/4 times 1/2. Now, if we look at our bar diagram, we see that we need to know what 3 units is equal to. Well, again, we just refer back to our models of, in this case, multiplication. If 1 unit is 7/4 times a half, then 3 units is that quantity multiplied by 3. So we see that 3 units, and the answer to the question is 7/4 times a half times 3. Now, if we think about multiplying a number by a half and then turning around and multiplying a number by 3, well, we know from our fraction multiplication discussion that 1/2 multiplied by 3 is 3 halves. So 7/4 multiplied by 1/2 multiplied by 3 is exactly the same as 7/4 times 3 halves. This is what we wanted to get across, right? We know that we started with the problem 7/4 divided by 2/3, and in the process of solving the problem, we see that the solution of this problem is the arithmetic 7/4 multiplied by 3 halves. Okay. And this is it. In every case, we had 4 cases: a whole number divided by a whole number, a fraction divided by a whole number divided by a fraction, and a fraction divided by a fraction. In each case, we stated a word problem in which it was clear what the correct operation was. And in the solution of that problem, we noticed that in each case, multiplying by the reciprocal of the divisor was the correct way of solving the problem. And we hope that this is enough evidence for our students to recognize that this is always the correct way to solve a fraction division problem. Okay. However, this last stage of fraction divided by a fraction is a bit tricky. It really heavily relies on knowledge of partitive division. Okay? For that reason, there's an alternate method of fraction division that is sometimes taught called the common denominator method, and that will be the content of the next clip.